Good morning, dear students. Today we will discuss on the quality control and quality assurance plan and few bituminous volumetrics terminologies. So let's start the journey with the quality control and quality assurance plan. For the quality control and quality assurance plan, first of all, we should know that what is quality control and what is quality assurance. So the first is quality control. The operational techniques and the activities that are used to fulfill the requirements for quality and all those planned and systematic actions that necessary to provide the confidence that a particular product or the particular service or the material that will satisfy the given requirements for the quality. That is all about the quality control. Now what is quality assurance? All the planned and systematic activities that is implemented within the quality system and demonstrated as needed to provide the adequate confidence that any particular entity will fulfill the requirements. So this is all about the quality control and the quality assurance. Now next we will discuss on what is quality assurance plan. The quality assurance plan is the methodology that is selected for ensuring that the project incorporates all the elements and that are needed for the successful design, construction and the maintenance of a project. The quality assurance plan should deal with the following aspects, and those are: first, selection of material, testing of material, acceptance criteria, guidelines for non-conforming material and works, and the last, that is documentation. So let's start with the selection of material, or we can say the sampling of material. The selection of the material. Now all construction materials to be used in the permanent works are to be sampled jointly by the consultant and the contractor. That has to be prior to the commencement of the work. This includes the sampling for materials that has to be tested for the proposing approval of the material source, as well as the sampling of material for approval of the individual construction materials. In both cases, the contractor must give notification of a request for such sampling to the consultant in advance, and for the sampling activities the consultant is to be represented by the material engineer. Now, all the sampling is to be carried out in accordance with instruction to be given by the consultant. The sampling procedures are to be followed as per recognized guidelines for the particular construction work. Now these steps includes when you are selecting the materials, that includes the following steps. The first, that is the sample that has to be obtained has to be from the at least 3 different areas. The second thing that has to be kept, that is ensuring that the sampled material and the location are typical for the material to be tested. The next, that has to be ensured that the all overburdens are removed within the stockpiles rather than from the surface. That in order to avoid the collection of segregated materials. The fourth is, it has to be ensured that the sufficient quantities are sampled to enable all the test to the conducted, plus the additional material that has to be stored for the subsequent testing, that if necessary. This point says that the particular engineer has to ensure that the sufficient quantities are sampled for that particular work. The next is, the engineer has to ensure that each sample of bag is marked or labeled both inside and outside, that will giving the sample number, material type, sample location, date and number of the bag, as well as any additional information instructed by the engineer. The label has to be kept so that the engineer can recognize which material have which characteristics. Okay, so these are the steps that has to be kept while you are sampling the particular material or selecting the particular material. The next step, that is testing of material. It is the responsibility of the contractor to ensure that the laboratory is proficiently protected at all the times of the day and night. It has to be daily cleaned and is properly maintained. The testing equipment and apparatus are to be kept initially approved and subsequently periodically checked by the consultant to assure proper operation, the accuracy, the correct calibration and complete conformance to all the specification requirements. The consultant is to supervise, monitor and check all aspects of the testing procedure, that including sample storage, preparation, testing and analysis and reporting of testing results. So this is all about the testing of materials. The next step, that is acceptance criteria. After selecting the material, the engineer has to make testing on that particular material, and then after, some acceptance criteria has to be followed. So in the acceptance criteria, all the materials that included in the construction works for which quality control tests are specified and for which the approval by the engineer has been previously given are to be inspected and checked for acceptability in accordance with the specification requirements. The kind of tests and frequency of testing should be conform to the minimum quality control testing requirements of the MORTH specification. Sampling and testing should be in accordance with the relevant IS methods. So this particular term, that is acceptance criteria, indicates that how much amount of testing you have to perform on that particular material. It says that to obtain the particular quality control, which are the tests, which kind of the test you have to perform, what should be the criteria for that particular testings that you will get from the IS methods and the MORTH specifications. The next is guidelines for non-conforming material and works. It is necessary that the materials and workmanship conform with the contract requirements, and ideally non-conforming work shall be rejected. Whenever the work falls short of the requirement, the matter shall also be brought to the notice of the employer. But in some special cases, some items of work such as concrete, where the non-conformance may only be known after few days of the Q results. So in such cases, the period work has progressed further already. So the acceptance after the repair or the review for adequacy is feasible in such cases. So therefore, the separate procedure are laid out for some of the non-conforming situations. In case the feasible items do not meet the requirements after such repair or the review, or we can say the maintenance work, the non-conforming item should be rejected. It is also necessary to refer to head office or to the designer in such certain cases of non-conformance to seek their advice and the guidance. After following all this procedure, Next, the site engineer, or we can say the supervisor, have to submit some documentation of that particular projects. So upon the completion of each contract section, the completion of the project, there are several documents that has to be prepared and that has to be submitted to the employer. The following should be checked with the employer as the project nears to the completion. The first thing, that is the as-built drawings, the final takeoff quantities and amounts, contract documentations, and the final completion reports. Although those final documentations are to be submitted at the end of the contract section, they have to be prepared as work progresses and finalized when the work nearer to the completion point. So this is all about the quality assurance plan. To complete the project as per the quality, such type of plan has to be performed. Now, next topic on which we will discuss, that is bituminous volumetrics. The properties of bituminous mix also includes the theoretical specific gravity, the bulk specific gravity of that particular bituminous mix, the percent of air voids, the percentage volume of bitumen, the percentage void in mixed aggregate, and the percentage voids that filled with the bituminous binder material. So these are the terminology which is from the bituminous volumetrics concept. So let's first discuss on theoretical specific gravity of the mix. The theoretical maximum specific gravity of a mixture, that is the specific gravity excluding the air voids. Thus, theoretically, if all the air or all the air voids were eliminated from the particular mixed sample, the combined specific gravity of the remaining aggregate and the bituminous binder, this would be the theoretical maximum specific gravity. The theoretical specific gravity is given as the following equation, that is GT, that is the notation of theoretical specific gravity, that is equal to the W1 plus W2 plus W3 plus W4, this whole divided by W1 upon G1 plus W2 upon G2 plus W3 upon G3 plus W4 upon G4, wherein this W4 and G4 is also notified as a GB and WB. Now, what this all terminology means? So here the W1 is the weight of coarse aggregate in the total mix. W2 is the weight of the fine aggregate in the total mix, wherein W3 is equal to the weight of the filler in the total mix, and at last the WB, or we can say W4, that is equal to the weight of bitumen in the total mix. Above all are of aggregate and the mix, and this is particularly for the bitumen. So W is equal to kind of weight, where G stands for the specific gravity of that particular material. So G1 is the apparent specific gravity of the coarse aggregate, where G2 is equal to same specific gravity of fine aggregates. G3 is equal to the apparent specific gravity of the filler, and at last G4 or GB is equal to apparent specific gravity of bitumen binder. So this is all about the theoretical specific gravity of the mix. The next terminology, that is the bulk specific gravity of the compacted asphalt, or we can say the bulk specific gravity of particular mix, that is notified as GM. The ratio of the mass in air of a unit volume of a permeable material at a stated temperature to the mass in air of equal volume of the water at particular stated temperature. This value is used to determine the weight per unit volume of the compacted mixture. It is very important to measure the bulk specific gravity as accurately as possible, since it is used to convert the weight measurement to volumes. Any small error in such terminology, that is bulk specific gravity, that will be reflected in significant volume errors which may go undetected. Now the bulk specific gravity or the actual specific gravity of the mix, that can be found out by following equation, that is Gm is equal to Wm upon Wm minus Ww, wherein Wm is equal to the weight of the mix in air, specifically in air, while Ww is equal to the weight of the mix in the water. And this particular equation will give you the bulk specific gravity for that particular mix. Here note that Wm minus Ww will give the volume of the particular mix. The next is air void percentage, or we can say the percentage of air voids, the total volume of the small pockets of air between coated aggregate particles throughout a compacted paving mixture, that is expressed as a percentage of the bulk volume of compacted paving mixture. The amount of air voids in mixture is extremely important and closely related to the stability and durability. For the typical dense graded mixes with the 12.5 mm nominal maximum size aggregate, the air voids below about the 3% result in an unstable mixture, while the air voids above the 8% results in water permeable mixture. Air by volume, that can be expressed as VV is equal to GT minus GM upon GT into 100. GT is equal to theoretical specific gravity of the mix and GM is equal to bulk specific gravity of the mix. This both terminology we have already discussed above, and we have the equations and we have the formula to find out this two terminology, that is theoretical specific gravity and the bulk specific gravity. The next terminology, that is percentage volume of bitumen. This can be notified as a VB. Here the volume of bituminous binder in the mix that has been absorbed into the pore structure of the aggregate, this is not accounted for the effective asphalt content. The volume of bitumen is the percentage of volume of bitumen to the total volume, and it can be expressed as VB is equal to WB upon GB, that is specifically for the binder, because here we are talking for the volume of bitumen. So that's why we have only take WB and GB, this whole divided by W1, W2, W3 plus Wb, that is the weight of again bituminous binder, upon Gm. Now we all know Gm is nothing but the bulk specific gravity of the mix, and same way W1, W2, W3 are the different weights of aggregates and the fillers, and Gb is the specific gravity of the bitumen binder. Yes, so next, that is the void in mineral aggregates, that is VMA. The volume of the intergranular void space, that between the aggregate particles of a compacted paving mixture, that includes the air voids and the effective asphalt content, that is expressed as a percent of the total volume of specimen. We can say when VMA is too low, that is void in mineral aggregate, that is low, at that time there is not enough room in the mixture to add sufficient asphalt, and if the VMA is in excessive amount, that will cause an unacceptably low mixture stability. So generally a minimum void in mineral aggregate is specified, and a maximum void in mineral aggregate may or may not be specified. Now void in mineral aggregate, that can be calculated as VV plus VB. So it is the addition of percentage of air voids in the mix and the percentage of bituminous content in the mix. So let's talk on the voids filled with bitumen, that is VFB. The portion of the voids in the mineral aggregate that contain asphalt binder. This represent the volume of the effective asphalt content. It can also be described as the percent of the volume of the voids in particular mineral aggregates, that is VMA, that is filled with asphalt cement. The voids filled with bitumen is inversely related to the air voids. As air voids decreases, the VFB value will increases. The value of a VFB can be calculated as VB into 100 upon void in mineral aggregate. We have the formula for void in mineral aggregate. Also we know how to find out the value of VB, that is the percentage in the bitumen content. We also know how to find out VB, that is percentage of bitumen content in the mix. So this is all about the bituminous volumetrics. This is a chart for a particular specimen to understand all this bituminous volumetrics. Thank you so much students for your kind attention. You got the thorough information about this all topics. Thank you.